Welcome back to the series on searching and sorting. In this part, we'll cover function pointers, which will be necessary to use comparators. Now that we have comparator functions, how can we pass them to a generic sorting function so that the sorting function can use them? As we've seen previously, it's a simple matter to pass variables either by value or by reference to a function. But what about passing a function to another function? How can we pass a piece of code? To do this, we need the concept of function pointers. Recall that a pointer refers to a memory location. Well, what's stored in memory? Variables, arrays, data, basically everything, including the program's code. When a program is running, its functions are stored in the program's stack somewhere. So we can have pointers point to a memory location that contains the code for a function. Having a pointer that points to a function means that we can pass that pointer to another function, effectively passing a function to another function. Often these functions are called callback functions, because the function that we pass them to is expected to call them back. Let's take a look at a full demonstration. First of all, let's cover the syntax for creating a function pointer. Now, a function pointer should only point to a function with a specific signature. Let's create a pointer that can point to a function that returns an integer and takes 3 arguments, an int, a double, and a char. To do this, we use the following syntax. ptr2func is the name of our function pointer. The syntax refers to the fact that it takes 3 arguments, int, double, and char, and it returns an int. The star is to indicate that it's a pointer, just as when we declare an int star or a char star. The parentheses are necessary to associate that star with the function pointer name. Now, how can we assign this value? Once it's declared, we can set it equal to another function. For now, though, let's just go ahead and set it to null. Remember that it's the best practice to initialize pointers to null when you declare them, unless you want to assign them immediately to something. ptr2func is just a pointer, so we can assign it a null value. Alternatively, we could have done this at declaration. Now, how might we declare a pointer that can point to the math library's square root function? Remember that sqrt returns a double and takes a double. So we would use the following syntax. It takes a double and returns a double. And I've named this pointer ptr to sqrt. Now let's make our pointer to sqrt actually point to the square root function. The name of a function is also its reference. It's also its pointer. So I can assign the name sqrt to my pointer. Once I have a pointer to a function, I can invoke it like any other function. Normally I'd call the square root function like this to get the square root of 2. But if I want to use my pointer, I can use the name of the pointer along with the parentheses. The omission of parentheses means that it refers to the function itself. In other words, the memory location at which that function is being stored. Let's see this in action. We didn't directly call the square root function. Instead, we called it via a pointer. We can also reassign pointer values. I'll make ptr to sqrt point to sign instead. The sine value of 2 radians is 0.9. Now you might be thinking to yourself, what use is this? We've already got sqrt and sine, and we can call those functions directly. Why do we need a function pointer? It's because we can design functions that take other functions as input references and invoke them. I've created a function that takes a double by value, but also a function pointer that points to a function that takes a double and returns a double. Now inside this function, we can run that other function. In this way, we can pass a function to another function so that it can actually use it. How would we call that function of ours? We're calling our run-a-function function, passing in 2, and a reference to the square root function. This will produce a square root of 2. Before we run this and test it, let's call it with a different input parameter. Let's call it with sine instead. The first time we call it, we get the square root of 2. The second time we call it, we get the sine of 2. In the next part, we'll cover how we can use this with comparators. We can pass in a comparator to another function, and it can use the comparator to order individual elements without having to know anything about those elements.